For the next 20-25 minutes, we will go over the details of GraalVM Enterprise and how it accelerates application performance for cloud workloads. We would specifically touch upon how to install GraalVM Enterprise, its features and capabilities, and what makes GraalVM an ideal platform for cloud-deployed Java applications. Once again, for the folks who have joined us today, I would just reiterate to please feel free to ask questions. And we have a Q&A box, as Sean mentioned, wherein you can type your questions, and we will get to them at the end of the presentation. Okay, so before we begin, be aware that this is a technical discussion and do not make any forward-going business decisions based on this. And also, I would want to mention that certain components of GraalVM Enterprise Edition are distributed as early adopter technology, so please be aware of that. Okay, so let's begin our discussion. In fact, let's begin our discussion with Java. Java is pervasive. It is the only language that is used by more than 55% of businesses worldwide. No other programming language is used as pervasively. Now, Java is the #1 programming language in the world, with millions of developers running more than 45 billion Java virtual machines worldwide. Java continues to be the development platform of choice for enterprises and developers. And with 25 billion cloud-connected Java virtual machines, Java is also the #1 developer choice for the cloud. GraalVM builds on Java and provides even higher performance and new capabilities. GraalVM Enterprise allows your applications to run faster without any code changes, work smarter by giving you predictable performance, stability, and security updates for all your Java and JVM-based applications, and run leaner by reducing CPU, memory usage, and costs. Let's take a deeper look at our topic at hand, GraalVM Enterprise for cloud workloads. Now, an intelligent cloud journey needs to balance performance and value. To be able to scale the applications with increasing demand and keep up with the SLA guarantees, the enterprises are incurring more and more expenses. This aspect is further highlighted on public cloud platforms, where the charges are based on both CPU and memory usage. Hence, there is a persistent need to find innovative ways to get more out of the existing investments. This includes resource consolidation and reduced infrastructure costs, increased workload efficiency, improved developer productivity, and overall shortened development lifecycle. Besides, the enterprises also seek faster issue resolution and easy maintenance and upgrades. To accomplish all this, to become more agile and enhance application performance, keep up with the SLAs, adding more and more compute and memory resources is not the solution. Instead, we have to continuously manage consumption and capacity with performance, and hence manage the costs. GraalVM Enterprise addresses these challenges. So, what is GraalVM and why is it so relevant to this discussion? Oracle GraalVM Enterprise Edition is an application runtime that addresses these challenges that we just talked about. Before taking a deep dive further, I would like to highlight the key value propositions of GraalVM Enterprise in this very context. The main components of GraalVM Enterprise include a high-performance optimizing just-in-time compiler for Java and JVM languages. This enables the applications to run faster without any code changes and work smarter by giving a predictable performance and stability. GraalVM Enterprise also includes an ahead-of-time compiler, whereby the program is compiled all the way to the machine code. This enables the programs to start up faster and need much less memory to run. This aspect is of particular advantage for microservices, and we will get to it in a lot more detail in the later part of this presentation. GraalVM supports multiple languages, not just the JVM languages like Java, JavaScript, and such, but languages like Ruby and Python through a language implementation framework. GraalVM Enterprise is built on Java SE. It builds on Java and provides even higher performance and newer capabilities. And lastly, working with GraalVM Enterprise gets you 24/7 Oracle support. In the context of today's discussion, to showcase GraalVM Enterprise for cloud workloads, we'll install it on Oracle Cloud Infrastructure and run some sample applications there. For cloud workloads, GraalVM Enterprise is included in all Oracle Cloud Infrastructure subscriptions, so you can use it for no additional charge. So before moving any further, it is important and interesting to note that while GraalVM Enterprise's improved performance and reduced resource requirements can lead to significant cost savings for OCI customers, Oracle Cloud Infrastructure itself is running services on GraalVM Enterprise. A good example is the Oracle Cloud Infrastructure Monitoring Service, which captures and provides analysis of service health and performance metrics. Just by dropping in GraalVM Enterprise, it has reported a 5% reduction in CPU consumption and a 10% increase in the number of transactions per second. So let's see how to get started with GraalVM Enterprise on Oracle Cloud Infrastructure. For OCI user workloads, GraalVM Enterprise can be used in the following deployment scenarios: bare metal and virtual machines, containers, which is the container native enterprise ready managed Kubernetes service, and functions, a managed service wherein you write, deploy, and run code without having to provision or manage your servers. So for our discussion today, we'll focus on the first scenario, using GraalVM Enterprise in an OCI virtual machine compute instance. Now there are two ways to install GraalVM. You can do a manual installation. There are detailed instructions available in the reference guide, or use yum to install the necessary Linux packages. And this is indeed the easier and recommended approach, as the RPMs are available in the OCI yum repository. So you use SSH to connect to your OCI instance, providing the private key associated with the public key that you use during the instance creation and the public IP address. Once you have SSH into your instance, verify what GraalVM RPMs are available for installation. Refresh the repo data and search for the available packages. Be aware that the output will be huge, as it will include both current and previous versions of the components. Look for the latest release and proceed with the installation. So for example, to install GraalVM Enterprise version 20.1 with JDK 8, we would run the following command. Once done, how do you verify your installation? You can do so by checking the Java version to confirm the correct installation and version of GraalVM, as shown here. Let's set the Java home and point the path variables to the GraalVM Enterprise installed bin folder in the bash configuration. Source the bash RC to get the changes in your current SSH session, and you're all set to go. So these were the quick steps to install GraalVM Enterprise. Later on, I have a demo for you wherein we'll see this accelerated application performance by GraalVM in action with a simple application. So as we are set with the installation of GraalVM Enterprise, I would want to briefly talk about the modern application development. Modern applications are increasingly moving towards microservices architecture. These applications are highly distributed, allowing for significant redundancy and reliability, and are designed to execute effectively in today's cloud environments, right? So to handle peak demand, it's also necessary that these services are able to scale up and scale down rapidly. However, in many deployment scenarios, it can take seconds or even minutes to add additional capacity to meet the spikes in demand. In this context, I would want to discuss one of the key features of GraalVM Enterprise, and quite relevant to our discussion today, by the way. GraalVM Enterprise's ahead of time compilation capability, whereby the code is compiled all the way to the machine code. This may take more time than a typical compilation, but then the application starts up much more quickly and needs much less memory to run, providing these specific advantages for modern microservices. Continuing on that discussion, in a typical cloud application, you have multiple services. Each of these services does part of the work for the application. But it is important to note that however each of these services has code that is unnecessarily sitting in memory, and it is unused but brought in because it's part of the library that is used by the service. It also means that the compiler and all its components are being executed at runtime. So with GraalVM Enterprise ahead of time compiler, you can compile those services ahead of time to run natively on the platform. It operates with a closed world assumption. This means that all the code necessary to run the application is available at compile time. This allows the compiler to remove any unused code from the application and reduces the need for the compiler and other parts of the JVM at runtime, significantly reducing memory consumption and startup time as the code is already compiled. Now this brings several advantages with it. First off, it addresses the initial problem we discussed. It means that services can now rapidly scale up and down. Also, removing unnecessary code also minimizes the application attack surface in your data center and in the cloud. Besides, it lowers CPU usage due to lack of compiler doing any processing during runtime. Applications use up to 5 times less memory and start up to 100 times faster with GraalVM Enterprise's ahead of time compilation capability. These precise benefits have led to GraalVM native image being the preferred way to run applications built by all the major microservices frameworks, including Heliton, Micronaut, Quarkus, amongst others. So let's see a practical example of what we just discussed. First off, a couple steps for installation. Be aware that native image comes as a separate installation, so we need to add it to the base installation. Search for the proper package name and proceed to install. In this particular instance, we are running GraalVM Enterprise 20 with JDK 8 support. Let's install the corresponding native image package. Next, I'm showing a sample usage of native image utility, the way to compile native images for your application. Overall, note that native image compilation times depend on application size and complexity and may take some time on low-powered VMs. So, it's time for some demos. We'll look at the accelerated application performance with GraalVM Enterprise, and in the second demo, also some specific benefits with GraalVM Enterprise with microservices. Okay, let's run some sample workloads to observe the performance of GraalVM Enterprise in the JIT mode and the AOT mode. Let's run the tests with and without GraalVM compiler. Without GraalVM will mean running with the default C2 compiler. Let's run without the GraalVM Enterprise first. As you can see, the GraalVM compiler is disabled using this flag. The idea is to run the benchmark with and without GraalVM and compare the numbers. Okay, so this iteration is complete and our score is 284 nanoseconds per operation. Can we get a better performance? We won't know till we run with GraalVM compiler. Let's do that. Okay, so this iteration is also complete and this time our score is 13.67, which compared to our previous run gives us roughly 20 times better performance running with GraalVM Enterprise. It is important to understand that everyone's workload is different and every workload will see different performance improvements. But the key takeaway from this effort is to showcase that such improvements are possible running with GraalVM Enterprise. So I would highly encourage you to try out GraalVM Enterprise today for your workloads in your environment and observe these performance benefits. Fine. So this was to showcase the performance of GraalVM Enterprise in the JIT mode. Now let's switch to the second demo where we would want to showcase the benefits of native image compilation with GraalVM Enterprise. Here, we will run a simple Micronaut application. We'll run it 2 times, first in the JIT mode, and then the second time we'll run an ahead of time compiled image for the same application. Let's run in the JIT mode first. So this application started in roughly 2.2 seconds. Let's check. It's a very simple application that is designed to return a random name from a list. Okay, so it's up and running. Now let's go ahead and kill this application and double check that it's disabled. And rightfully so. For the second run, I already have a pre-compiled GraalVM native image,
So let's run it as a native application. As you observe, this image started in roughly 260 milliseconds. And it's up and running with the same functionality.
What we saw in the demo was a Micronaut application. Here are the measurements of the startup times for the popular microservices frameworks. GraalVM ahead of time compiled microservices start up in the low double-digit milliseconds versus nearly 1 second or 2 seconds otherwise. What's the business advantage of this performance benefit? You no longer have to have services running, consuming memory and CPU, costing you real money just waiting for the demand. You can deploy new instances of services on demand and shut them down when they are needed, saving you your cloud costs. The key takeaway here is that it doesn't matter what framework you choose. You will see performance benefits and boosts with GraalVM Enterprise. Not only that, ahead of time compilation and running native binaries significantly reduces the amount of memory required for the microservices too, as is shown here, comparing different microservices frameworks. The gain is observed with GraalVM Enterprise, giving you complete flexibility to choose your desired framework to work with. In the light of this discussion and these figures observed with benchmarks on other frameworks, I want to revisit and highlight the details that we observed during the demo. We observed the difference in the startup times while running the Micronaut application as a native image versus running the same application in the JIT mode. Now, notice the difference in the startup times here and how they compare with the benchmark numbers that we saw earlier. Besides, the executable is a self-contained binary and does not require a GDK to run, which makes it an easy way to distribute applications, right? But startup time is not the only benefit that native image compilation brings. For our demo scenario, let's look at the CPU and memory utilization and compare it in the JIT mode and native image mode. Now, in the JIT mode, CPU is quite busy for until the first 2 seconds. And also notice the memory usage. But now, notice the scale for the CPU and memory for the native image run. The scale on the left capturing the percentage CPU and on the right capturing the real memory for our runs. Do you notice something unusual here? The chart for the native image mode is magnified multiple times. If I were to really draw these charts to scale, you would see something like this. You would really need a magnifying glass to observe the CPU and memory used by native images compared to the services running in just-in-time mode. And that, to me, is the key takeaway from that exercise. These benefits have led to GraalVM native image being the preferred way to run applications and services supported by all the major microservices frameworks, including Helidon, Micronaut, Quarkus, Spring Boot. So overall, the choice is really driven by the workload. As of today, the ahead-of-time compilation and just-in-time compilation are better at different aspects of workload needs. While native image is ideal for fast starting and relatively short-lived microservices, just-in-time compilation is a better option for traditional long-running Java workloads. However, as we move forward with new enhancements to GraalVM Enterprise's AOT compiler, it will become just as good as the just-in-time compiler in all aspects, except that it will continue to operate in the closed world assumption. So dynamic applications and applications that do reflection will continue to be best run in JIT mode. So to conclude, I would like to leave you with this quick summary about what makes GraalVM Enterprise the perfect platform for cloud deployed Java applications. Accelerate your application by making GraalVM Enterprise just a drop-in replacement. GraalVM Enterprise can make your applications faster by up to 55% without any code changes. Lower your infrastructure costs. As we observed earlier, microservices running on GraalVM Enterprise consume less memory and CPU. This reduced resource consumption helps lower your infrastructure costs and hence your IT bill. Besides, as we discussed earlier, GraalVM is supported by all the leading Java application frameworks. So you get to work with the framework of your choice. The support for multiple languages by GraalVM Enterprise drastically improves developer productivity. Traditionally, this has been difficult for a developer to incorporate libraries from any language into their Java application, thus allowing them to take advantage of the unique capabilities of that library. This would ideally introduce significant performance penalties. Well, until now. GraalVM Enterprise provides high-performance runtime support for a number of languages beyond Java, along with the ability to have different languages and libraries interoperate with no performance penalty. This support improves developer productivity by letting them use the right language or library for a given task. And lastly, GraalVM Enterprise is production ready. Its support is included in the Oracle Cloud subscription. Besides, Oracle Cloud Infrastructure Compute is anyhow cheaper than other public clouds. To add to it, you get accelerated application performance and reduced resource consumption with GraalVM Enterprise. To learn more, visit oracle.com/GraalVM. So this wraps up my presentation today. I sincerely thank you all for tuning in.